We are going to see the different parts of lathe. In lathe, we are having lathe bed. The lathe bed is made up of chilled cast iron. Why it is made up of chilled cast iron? Because chilled cast iron has the damping property. It is able to absorb the shock and vibrations. So in this bed, there are three major components are placed. The first one is headstock, and then is carriage and tailstock. These three are the major three components which are placed on the bed. So types of lathe bed, we are having different types of lathe bed. One is flat type lathe bed, inverted V type lathe bed, and combination of both flat and V type lathe bed. Next we are going to see about the headstock. Headstock, which is located on the left end of the bed. It comprises work holding device, spindle, gearbox. So power supply is provided in the headstock. So based on the power supply provided in the headstock will rotate, headstock spindle will rotate. The next is spindle. Spindle is the hollow cylindrical shaft having external threads and internal taper. It is having the external threads and internal taper. The taper is made up of Morse taper. We are having different types of taper. Here the taper provided, the name of the taper is Morse taper since it was invented by the Morse. Spindle supported by the thrust bearing in headstock. Next component on the lathe is tailstock. The tailstock is just opposite to the headstock. Headstock is on the left side means the tailstock is just opposite to the headstock at right end of the lathe. Its purpose is to hold the long workpiece at the other end by attaching the dead center. We are having two centers, live center and dead center. The spindle mounted on the headstock, the center of the spindle mounted on the headstock is called as a live center because it is able to rotate. The center of the spindle mounted on the tailstock is called as dead center. It is not able to rotate. To hold the tool for performing some process like drilling, tapping, reaming. So for doing these operations, this tailstock can be used. Drilling is the hole making operation. Tapping is the internal thread making operation. Reaming is the hole finishing operation. Here we should remember that tailstock does not rotate, but tailstock itself can move to and fro motion on the lathe bedways. So the next thing we are going to see is carriage. This carriage is located between the headstock and the tailstock. So in one side headstock is there, other side tailstock is there. This carriage is located in between the headstock and tailstock. It is fitted on the bedways on lathe, can slide along the guideways. Consists mainly 5 parts. The first one is apron, then saddle. Saddle is H shape it has, cross slide, and compound rest. That can be swivel and top slide, and tool post. So these are the 5 important components in the carriage. Specification of lathe பார்க்க போறோம். We are going to see the specification of lathe. The first one is height of the center above the top of the bed. So we are having the bed portion from that. So this height of the center from the top of the bed. The next thing is swing or maximum diameter of workpiece that can rotated over the ways of the bed. So we can hold the workpiece on a chuck and it is able to rotate without touching the bed. The swing or the maximum diameter workpiece that can be rotated over the ways of the bed. The next thing, the maximum length of the work that can be accommodated between the center. So we are having live center and dead center. So the maximum length of the workpiece that can be accommodated between the lathe centers. This is live center and dead center. The next point is the maximum diameter of work that can be rotated on the lathe spindle. When a workpiece is placed on the spindle, it is able to freely rotate. So that maximum diameter of the work that can be rotated over the lathe spindle. So maximum length of the workpiece, the swing maximum diameter workpiece that can rotate on the base of the bed, and height of the center. So these are the four major specifications of the lathe. What do you mean by plane turning? We are going to discuss about the different lathe operation. What do you mean by plane turning? Plane turning is the process or operation. We can get the cylindrical workpiece. The process of reducing the diameter is termed as turning or plane turning. So it is the operation of removing the excess amount of material from the surface to obtain the cylindrical workpiece. That is the plane turning. The next one is step turning. Operation of producing steps of different diameter in work. So if it is diameter, the 30 mm diameter is reduced to 20 mm diameter, is termed as plane turning. When the 30 mm diameter is reduced into 25 mm, 20 mm, 15 mm, like that, step by step of different diameter, it is called as step turning. The process of reducing the dia suddenly to the different diameter is termed as step turning. The next is taper turning. Taper turning is the process of producing the external conical surface on the workpiece. The process of reducing the dia gradually is termed as taper turning. The process of reducing the dia gradually is termed as taper turning, or the process of making the external conical surface on the workpiece is called as taper turning. The next one is undercutting or grooving. It is the operation of reducing the dia of workpiece over a very narrow shape. Undercutting or grooving is termed as the process of reducing the dia of workpiece over the very narrow surface. The next important operation is threading. The process of cutting helical grooves on the external cylindrical surface of the workpiece is termed as threading. The external cylindrical workpiece is made the cutting helical grooves. Knurling, the operation of embossing a diamond shaped pattern. So when for gripping purpose. So here the diamond shaped pattern can be made. That type of operation is called as knurling. Chamfering, the process of beveling the extreme end of the workpiece. The process of beveling the extreme end of the workpiece. So we are having the extreme end. This extreme end is beveled. So it is cut at 45 degree. So this is important in the case of thread cutting operation. It is essential operation in thread cutting operation. Next is boring. The process of enlarging the hole already made in a workpiece is termed as boring. The process of creating the hole is the drilling. The process of enlarging the hole already made hole is termed as boring. Next topic is taper turning. In taper turning, mostly in competitive exam, it is a question prone zone. We are having three different methods in taper turning by using form tool. So we are having the tool which is shaped in the form of taper. So the shape of the cutting edge is desired taper. Based on that, we can get the taper. The outer dia on the one end is capital D, inner dia on the other end is small d. So this angle is alpha, and this one is 2 alpha. The next method is by turning by the compound rest. Compound rest, we have to calculate the tan alpha. Tan alpha is nothing but capital D minus small d divided by 2L. By using this formula, this swiveling angle can be find out, and it has to be set in the particular angle to achieve that. So entire length is L, and where the taper is produced is small l. So here we are using the small l, and based on that, the capital D minus small d is this distance, l is this distance. So it is 2 times of here. The capital D minus small d divided by 2 is this distance, and we have to divide by L to get the tan alpha angle. The next method is tailstock set-over method or tailstock offset method, in which sine angle can be calculated by x by L. Tailstock offset, where x is the tailstock offset distance, x equal to L sine alpha, alpha is the half taper angle. As the half taper angle is very small, sin alpha equal to approximately equal to tan alpha. Tan alpha we all know that d minus d by 2l. So we are substituting sin alpha instead of sin alpha. We are substituting this value d minus d by 2l small l into capital L. We can get the x is termed as tailstock offset. The next thing we are going to know about is types of lathe. We are having different types of lathe: speed lathe or wood lathe, engine lathe, tool room lathe, capstan and turret lathe, special purpose lathe, fully automatic lathe. These are the different types of lathe. And then we are going to calculate the tool offset error. Tool offset error above, when the tool offset is above, the alpha effective increases. So alpha actual plus theta, we have to add theta. When and then gamma effective will be reduced, that is equal to gamma effective minus theta. Therefore chip flow increases. When tool offset below, the alpha effective will be downwards. Therefore alpha actual minus theta and gamma effective will be upward. It is vice versa, so you can easily remember gamma actual plus theta. Here rubbing action at the flank will be decreases when tool offset is below. Rubbing action at the end flank will decreases. Note, we have to note one important point. In boring operation, the tool is placed above the central line. Therefore, we can get alpha reduce and C effective will be increases. And below the central line means alpha increases and C effective will be decreases. We are going to see the different parts of the lathe. So in the lathe, we are having headstock, tailstock, carriage, cross slide, compound rest, apron, off nut, also called a split nut, lead screw, tumbler gears, mandrel, chasing dial, step cone pulley, steady rest, face plate and pipe center. Among these parts, any one of the parts may be asked in the exam. So the live center is located on the headstock. Live center is the center of the spindle placed on the headstock, which is able to rotate, hence it is called as live center. The next one is dead center. Dead center is the center of the spindle which is mounted on the tailstock. Carriage consists of cross slide, tool post, apron and compound rest. What is the function of cross slide? It moves radially, controls the radial portion of the tool in the facing. Compound rest is used to swivel the tool positioning adjustment, and in compound rest, power feed not available. Apron is the manual or mechanical movement of, with the help of apron only, we are providing the manual or mechanical movement of the carriage. The next is off nut also called as split nut. With the help of off nut, power is transmitted from the lead screw to the carriage. It is also used to lock the lathe carriage to the lead screw for thread cutting operation. Specifically, it will be helpful in the thread cutting operation. And then we are having lead screw. Lead screw is left-handed thread. It is from L itself, you can remember, it is a left-handed thread, and it is a backlash eliminator also. Then what is the purpose of tumbler gear? Tumbler gear gives the desired direction of the movement to the lathe carriage. Whether it has to move in which direction, it has to be decided by the tumbler gears. And we are having the mandrel. It is a work holding device used for holding a reamer workpiece, require machining at the both ends, or previously drilled hole can be tanned. So for these two purposes, the mandrel can be used. It is used for holding a reamer or workpiece, require machining at the both end, or previously drilled hole can be tanned. Chasing dial is the attachment used for the thread cutting operation, and step cone pulley, it is used to change the spindle speed. The steady rest is important question. It is used to mount the heavy and long workpiece. Face plate is the irregular shaped workpiece, can be mounted with the help of face plate. Face plate is the plate which consists of different diameter holes. This is a plate means it may be consist of many holes. So this type of plate is called as face plate. And pipe center, it is a center used for holding the hollow jobs. We are having different types of chucks. Chucks used in the lathe are dog carrier, face plate, collet, mandrel. These are some of the chucks. And we are famous chuck is 3-jaw chuck and 4-jaw chuck. For 3-jar chuck, always scroll plate is incorporated along with that, and it is self-centered. 3-jar chuck is the self-centered. All the jars move simultaneously and release simultaneously. 4-jar chuck is independent centered. For setting up a heavy and irregular workpiece, this 4-jar chuck can be used. It is accurate centering. By using the 4-jar chuck, accurate centering can be done. It can be used for heavy speed shaft turned by carbide tools on the center lathe. Centering can be done most accurately for machining a brass casting on a lathe. So in some cases, magnetic chuck is used. Magnetic chuck is used for the mass production. If a large number of components are turned and parted from the bar, we can go for magnetic chuck. And the collet chuck, when small size cylindrical jobs are made, then the collet chuck can be used. The small size cylindrical parts are separated with the help of parting of operations. And then we are going to use the combination chuck. The combination chuck is used for quick setting and accurate centering. When two purposes needed, quick setting and accurate centering is needed, we can go for combination chuck. This is salient points in the lathe where we can use the pair of tumbler gear. In which machine pair of tumbler gear is used? That is the question. We have to use in the center lathe. And name some accessories for the lathe. The best example of steady rest and coolant pump. Lathe centers are provided with the standard taper. That taper can be called as Morse taper. It is an important question. Its ratio is 1:20, or in some book it may be mentioned at 1:24. Left hand tool. What do you mean by left hand tool on a lathe? Cut most. When the left hand tool it cut efficiently when it travels from left to right. Spindle speed. The spindle speed are usually available in the geometrical progression. That is an important question for the competitive examination point of view. Back gear is engaged in the back gear deadstock. Then the spindle speed must. That is the thing you have to remember. Spindle speed will be minimum in case of thread cutting and knurling. So for thread cutting operation, knurling, the spindle speed will be minimum. Slow spindle speed, thread cutting, turning odd or tough material, turning a large diameter, turning operation. With the decrease in diameter of work, the spindle speed must decreases. So these are the simple points we have to remember. During the back gear engagement, the spindle speed must decreases. Taper turning, that we are using the different taper turning for the different specific application. For turn shaft, turn short length of the taper, we can, with the help of broad nose itself, it can be done. Setting over the tailstock method, small taper on the long job. The setting over tailstock method, tailstock offset method can be used for small taper on long job. And live center, dead center are not equally stressed. This is the disadvantage in the set over method. Because of this, non-uniform wear take place. The next method is fiveling the compound rest. It is for short but steep taper. This is small taper on long job. This one for fiveling the compound rest can be used for short but steep taper. Tool is fed at an angle. This method is disadvantage, low production capacity. Then we are having the taper attachment method. Taper attachment method is used for steep taper or long pieces are possible. This is the accurate taper, and this will be best method for the internal taper. That is the important point we should remember. The taper attachment can be well suitable for internal taper. And combining feed method, it can be used for both longitudinally and cross feed can be engaged simultaneously. That type of method is called as combining feed method.